The first thing to do is hook up these other motors. I put two yesterday, so first unplug the battery. Then we need to unplug this. Luckily they're color coded, so it's fine. And then I can just unplug these, I suppose. So first, I need to plug or connect these two sockets to these pins. So I'll do that with some wire. Get my wire. And I did this one goes to A, this one to B. I guess I'll put this one to A, other one to B. That makes sense. That, I guess. And this, I think, was 20 gauge wire. Yeah. It's a minute to heat up. Need to be soldered there. Hey, I am dual streaming to Twitch. Yes. Yeah, I figured like I like streaming to Twitch, but most of my audience is already on YouTube, so I should probably just stream it there too, or at least exclusively to YouTube. So I decided to just go ahead and do dual streaming. This is going to motor A. Yeah, and just so you can see it, I have two of these motors wired up. I'm just going to wire up these other two to my motor driver, and these are the two. This is each of these motor driver modules can control two motors, so I need two of them, and so I'm hooking this up to the other two motors. And the other things on here, this is the BMS battery charger, so you can just plug it in USB like you would your phone. Battery plugs in here, and this is a boost converter. So the battery is 3.7 volts, and this boosts it to 6 volts, which is what the motors use, and I also use that to power the microcontroller. But today I hope to first finish off the wiring, and then also program it to be controlled over Wi-Fi. Which shouldn't take too long because I just did it with I'm working on this video right now. I'm just working on the voiceover, but this potato head toy thing I got from a surplus store, and that too, I shouldn't say hacked, but I modified it to use one of these microcontrollers, and you can just move it around over Wi-Fi. So basically just copying that code from 4 motors instead of just one. Pins. So did I had red going to the right side? Yeah. It goes to this right pin. Well, don't want to melt the connector. Done that before. It's annoying. Or the wires. Or my hands. Okay, so that's good. Yeah, and for this stream, I'm going to be doing it all in MicroPython, just because it's easy to kind of get something running with that. But then I plan to, once I get sort of the first prototype done, I plan on using embedded Rust, just because I want a bit more of a challenge and a learning experience. I'm going to switching from so this is a ESP 8266 microcontroller, and be switching to, let me get tweezers. And be switching to a ESP32C3, and I'm going to be doing it with I guess I'm going to start off with um, standard library, but then I might try at some point using an OSTD. Um, it's I believe so. I don't know. I my first time doing using sockets was the other day, but here I can show you the code if you want to just see quick. I used to solder with an iron without control temperature. Something melted. They're like melting wires and connectors and stuff. Uh, yeah, so this is the code. Let's see. I think it's I think it's just using TCP. But yeah, it's basically it's you know it's a web server, and then you send it these commands. So if you do /move and then do /move and then you do like what is it, like question mark equals F, then it goes forward. Let me switch the view back. This camera. Okay. So then I'm going to connect that one. So how's my microphone? I think I improved it. I think the last time you saw the video, I was trying to do a noise gate because my 3D printer was running in the background. And then I was sitting over here, which is about 2 feet from my microphone. And then it wouldn't quite pick up when I was talking. But now that I'm not running the printer, it seems like it's pretty good now. Of course, the quality's not great, just because I'm out in an echoey workshop. Add a little bit more solder. All right. It's going to go up to this motor driver. So let's strip these wires. Yeah, and I think the video, I don't know if I published it on Twitch, but I know it's on YouTube. Uh, it's I managed to get this thing driving in one direction, which is kind of big because this is like I have this. This was the original one, kind of like in pieces now, but it's a lot smaller. I was planning on doing it all sheet metal, and so I kind of did a mock-up 3D print and just completely the pieces were too thin, they're flimsy, and uh, the suspension was too strong, I think. But this design actually works, and it can go over like little bumps. So I can lay my finger down in front of it, and then it can drive over that with like one wheel. So the suspension is doing work. And it can go over those little ridges people have in their homes that go along doorways. That's as far as I've tested. And it goes slow enough that the cats are comfortable bullying it. They're not scared of it, so that's also kind of nice. Oh, thanks. I do celebrate Thanksgiving. I plan on going over right after this to my parents' house. I just wanted to get this done quick because I want to bring it over and then mess with their cat with it, drive it around and play with the cat. I need a little bit more solder than that. Okay, let's get this pin connected. It might be broken a little bit. Bridge these connections. Definitely not. It's a little to see what's going on there. Oh yeah, it's kind of insulation's melting. Let's get that in. Yeah, that's a good connection. This one, okay, just pull it off. I'm gonna just see if I can strip this one. It is about the speed of a Roomba, so that's why I think all of my cats have experience dealing with Roombas, and I think they're comfortable. I feel like they have an edge over the Roomba, so it seems like it's very cat friendly, and they don't even bother kind of hitting it that much. Even they just kind of like to watch it, and I think it's more. I think the only thing they don't like is the weird sound it makes with the motor gearboxes. Let's see if I can get this on. Just need to get a little bit more solder on this, and then okay, that's good enough. Good. So that is all the motors hooked up. Now to the drivers. So this is good. now what I need to do is get the two more connectors onto the motors. So I'll do that next. Just take all these wires first. So you're still doing some Bevy stuff? I'm trying to. I just saw Bevy 0.9 came out, so I'm trying to. I've just started updating my game to 0.9, but it's not quite there yet because I'm spending time on stuff like this. Get a little bit more solder on that. Okay, so that one's good. Stick this up into this one now. There. Good enough. And that's good enough. Is it good enough? Yeah, it's good enough. There's all my motors now. So now I'm going to get all of this stuff plugged in. That's going to be a little annoying. Do it like this. Shove this here. Okay. And then I want to hook up these motors to their respective brackets. GitHub's game off, but we just wrote down the idea. I didn't realize there's a GitHub game off, so it's like a GitHub has their own game jam, I'm guessing. that one in first socket. Good. This goes in the second socket. Yeah, for the next version, I'm probably gonna have them go all the way up to the top because this is really not great. This is going. This one's in, this one's in. Let's do this one. This second. Okay, there's all the motors plugged in. Hey Jeff, who gets to be the first person to test out controlling the robots? Well, you of course. I already promised you get to do it, so why would I let someone else do it? I'm gonna go back on that. I don't think I posted this driving. I don't think I posted this. I have a video of Sven watching it drive. I don't think I posted that anyway yet. I'll show you that. I wanted to get a better video of it being fully controlled. Right now, it can just go forward when you power it on. Get this battery plugged in. This is very difficult to get in. I should have moved all. I don't know why I put the electronics in this bottom chamber. They're not even accessible. I have to do everything with forceps. Okay, battery's plugged in. Okay. This should work now. Well, after I put the microcontroller in, it should do something. So each wire needs 2 data wires to give it the control command. And then if I, oh crap, I forgot to pass the power thing up. Where is that? Here it is. There it is. So when I plug this in, it should start to move. I don't know if it will. Well, let's find out. Yes, there it goes. So right now it just drives forward, and then I can hook up these other. Yeah, so it's good. It can get over my finger, but if there's like a wall like this, for some reason it just can't. I think the wheel just. It's probably just the way it's approaching, because I can't get over my finger like that either. So it might just be that. But it can get over like some ridges. I wonder if I have. I'm not a good example here, but it can get over. Oh, I just got over it. It can get over the ridge between doors that are in homes. I can get over that. I guess it just needs a gradual slope. So I'm going to tape this down so it doesn't short, and then plug it in. And I need to suspend this so it doesn't drive off. I'll just use these helping hands. This battery's falling out. Get that in the frame. I can't see this wheel. Maybe I want it like this. If I can get it like that, can I prop it up on something? For chance. That's not bad. If I can just stick something under there. Okay. So I'm also going to just see where the battery charge is at. So this is USB multimeter. And so I can plug this in. Plug this into the USB on the BMS charger. Okay. And then plug this into my USB power thingy. Yeah, so it's, no, you can't see it. Charging at an amp. So I'll let that go while I'm programming it. It's supposed to last, so these motors, I should see how much current they take and see how long this battery will last, but this battery is huge. It's 6,600 milliamp hours. That's 6.6 amp hours, which means that if you run it at 6.6 amps, it should last an hour, which I'm not running it nearly that long. Let me just change the focus. So drag the window. There. Where did my... Okay, there it is. Okay, that's kind of in focus now. Sure. So then I just need to plug this in. Let me grab some more of these jumpers. And I'm just going to do male to female, so then I can just plug these pins into my microcontroller pins. So in blue and gray. Okay, so those are extended now. So I'm going to switch my view. I just saw, so did manage to integrate LDTK. LDTK, that sounds like a lightweight development toolkit. Level editors. Level designer toolkit. I was close. Oh, that's so cool. Interesting. So, wow. So is there like a Rust crate for this? Or what did you... How much I have to look at your code? Because I'm curious for... I don't really want to redo what I do for Theta Wave because it's just not like a platformer. But I might take a look at that and see if... At least for... I want to continue one of my Game Jam games. We did Cheaters Never Win. And that was really fun. And I'd like to continue it. And maybe I'd use something like that. Let me change my view now. Monitor and workspace. There. So I just need to plug this in. First I'll actually power it. Oh, it's hitting. Same mistake I made yesterday. There. And let's plug this in. Stick it like that for now. Oh, thanks. See you later. I think you posted a while ago, but thank you. Okay, so this is on now, so I can do stop. The first thing I want to do is get rid of all these arguments. This is getting a little ridiculous, so I'm going to remove these. Let me just change this to stop. I'm just going to save it as I think it's on there now. So I can type move forward. Move backward. Oh, got to. And stop. Yeah, I think just having them as globals makes sense. So then I should do 5, 6, 7, and 8. For the other ones, in 5, 5, 6, 7, and 8. There. So let's open this. And so I'm using 5, 4, 14, 12. So let's try 13, 15 for the next one. So I'll do, those are the ones right now. So in 5 and in 1 on this one, which should be gray, I believe. I can't see in there. There's a flashlight. I put that. I had a flashlight right before the stream. I didn't know I put it away because I thought it was in the way, and now I can't find it. Okay, I have a phone. Yeah, so it's gray. Gray is 5, so I'm going to put gray into GPIO 13, which is this one, which is D7, and then blue into GPIO 15. Okay, that one's so I shouldn't use that one. I have to Google this, which pin to use. Node MCU. Node MCU. I can only use 11 of them because 6 pins, 6 through 11. So 6 through 11 I shouldn't be able to use. Does that line up 6 through 11? Well, it's not showing those. Best pins to use. Okay. Okay, so I'm using 14, 12. So I should be able to use 0 and 2 but they're going to do kind of weird stuff. So let me, before I plug these, I'm going to move these up to 0 and 2. And it should start to move, but I think I can fix it in my code. So I'm going to do that. So if I go to Thani and go change this to 0 and 2. And let's comment these out for now. The reset button. Yeah, so you reset it. It just turns on for a second, which is not great. And which pin is that? That must be... It must be pin 2. So GPIO 0 is fine. So let me go here. So 0 is fine. 2 is high at boot, and that's why it's moving. So if I move D4 to pins down, or GPIO 2 to 3 pins down, there. Now it should... So it's on 14. It's not on 2, it's on 14. So let's change that. Save and reset. Now it shouldn't move when it starts. And I should still be able to do move forward. No. It doesn't like that. So now it's not even. Put on the right pin. Yeah, put it on 14. So maybe GPIO 0. What do you think? Because it's on 14. Yeah, maybe those aren't good to use. Okay, I'm gonna put it back where it was. What? Wait. What's going on? Oh yeah, I moved it on the wrong pin. Okay, so that's now it's on 14. Let me just verify that. So I can do move forward, move backward, stop. Good. Okay, so that's good. Let me just reset it, make sure everything works. Yeah. So then I'm just, yeah, that's just one pin I'm not using. So then let me go to back to here. So I'm going to use 12 and 13 for the next motor. So gray and blue, 12 and 13. So let me go here. 5 and 6. This is 12 and 13, right? I think that's good. Yep. And then I'm gonna make a new function called move right. Move right. So this one, I think first in all of these, you just want to call stop, because you have to stop the other direction. So here I'm going to call stop, and then I'm going to call in 5 dot value 1, in 6 dot value 0. And so that should now move the whole thing to the right. Except it's going to move one motor. Move right. There it goes. You can't really see it because it's the back one, but let me hook up the other one now. So I'll just, what if I do move forward from this? Okay, that did not stop. Oh yeah, because stop doesn't do anything with those motors, right? Motor 3 in 3 or in 5 dot value 0 in 6 dot value 0. Yeah, so I didn't change the stop command. So now save that, restart. Now it should, so if I type move forward, that goes, and I move right, stops, and that turns on. And I can use stop. Okay, good. So let's get the next motor in. So I'm using 12 and 13, so I'm going to use 15. And I don't think I want to use these, but I think this is what I'm using to communicate with it over, over the MicroPython REPL serial. So I'm going to do GPI of 15, and I'm going to do GPI of 10. Or maybe I'll just do 10 and 9, so they're next to each other. Yeah. So that... So 10 and 9, that's purple. I want on 10. It should be labeled SD3. That is the 1, 2, 3, 4th one down. Interesting that it stops when you do that. Kind of worries me. What does the website say about those pins? Oh. It kind of says, like, don't use those. So I can use 16. Let's do 16 and we'll do 16 and 15. Yeah, because I think these ones are kind of being used. So we'll do 16, which is this top one, and 15, which is D8. So that should be the next one down. Yeah, there's 4 pins. Okay. So we'll do 16 and 15. Yeah. Let's go back to Fani. We'll do 16, 15. Sixteen and 15. So first let's add it to stop. So we'll do motor 4. Okay, so then move right. Call this motor 3. Motor 4 in 7. Dot value 0 in 8 dot value 1. So now it should move both motors to the right. So let's see if that works. So we're going to set it. So that one does something on boot, which is a little annoying. So let's just type move right. Good. So I think for this microcontroller, I probably could do something so it doesn't do that, but I'm gonna change this anyway, just a proof of concept. So it's gonna like twitch a little when you turn it on. So then let's see. Let's add move left, and that's just the opposite of this. So just change all 0, 1, 1, 0. So now it should be able to move left. And move right. And move forward. It might be backward. Good. So let's stop. That's all the movement is done. I'm going to add 2 more movements that are kind of unique to this kind of car. And basically can turn on it can basically turn without moving because it has 4 wheels and you just move them all in the same direction. So I'm just going to have another command called turn right. And that's when you basically just move all of the motors in the same direction. So let's just copy this. So I'm just going to set the first in for all of these to, let's see what that does. I think that might do it, but it might not be that simple. So I'll do turn. Also, it's not really centered. Well, let's do a turn right. I think that's working. So I think so. All the wheels, yeah, all the wheels are going in the same direction now. So that is good. And I can do stop. And then I'll copy this and call it turn left. And that'll move them all in the opposite direction. So I'll just change all of the ones to zeros and zeros to ones. Save that. So now I can do turn left. And then turn right. There. And stop. That's good. Now, I think it's time to add a Wi-Fi control. So this shouldn't be that hard because I've already done it before. And it's kind of already in the code. I just commented out. So we're going to initialize the motor off. And then we have connect. Let me just uncomment this. Uncomment. Okay, so connect to Wi-Fi. It's going to connect to Wi-Fi using the... These are two constants it's importing, so those are already in... Those are already on the device, so this is going to work. Start web server. Port 80. And listening, so while true, it's going to accept a connection. I mean, this should do something. This should work for moving forward and backward without even touching it and stopping. So I guess I should just try it and see what happens. I just have to make sure I get the IP right. So let's save this and reset. And then I'm going to, on my phone, figure out what its IP is. I have an app called Fing that sort of sniffs all of the devices on the network. So first we have to see if this is actually connected to the Wi-Fi. And you can see that there's an infinite loop running, so the REPL's not available. I should be able to cancel it with Control-C, though, if I want. Okay, 10 online devices. Smart device. Maybe I should print the IP. I don't know which one it is. Also, it might not have the right Wi-Fi thing. Just open it up. Let me Control-C. File. Open MicroPython device. Wi-Fi. Yeah, I need to change this. So I'm going to change this to... Make another console called SSID Workshop and change it to what this one is. So just copy this And what is the Wi-Fi name out here? Okay. So let's, oops, let me undo that. Okay. This is the Wi-Fi out here, so let's save that. And then I'm gonna go back out here and change this to which one is it connecting to? Yeah, workshop. Okay, let's see if I can find the device now. So let's go to Thing, my phone. Refresh. Okay, what did it find? Smart device. Smart device. I don't know which one it is. Okay, maybe it's, I should check. So let me just comment all of this out, the infinite loop. Comment out. Save this. And reset it. So there should be a command to just view the IP, assuming I'm on. Yeah, so I found that. Let me just find the dot ESP8266 docs. MicroPython docs. Quick reference. I just want networking. ifconfig. It's .23. Does that show up on here? Oh yeah, there it is. .23. Okay, so that's my IP. So now I can uncomment all of this and run it again. Uncomment. Save. Reset. And now on my app, I can go to, but you know what the issue is? I just realized something. Let me go back to Fani. Yeah, I'm passing in these values still. So let me just change all of these. Because I just made these globals because I didn't feel like passing in 8 parameters to each of these functions. I think that's a little bit extreme. Okay, so let's save it, or cancel out of this loop. Save. Reset. Now it should work. And let me go to my app now. I think it's just called Wi-Fi ESP8266. Just an app for controlling a car. It has like some buttons you can push on your phone. I'll show it in a second. So move forward, move backward, turn right, turn left, and stop. Okay. So yeah, let me change this to 23. Now if I go to button, there it goes. Okay. show this on camera. A little hard to see. Maybe back here. Yeah, you can see the arrows, I think. So I do forward. So yeah, that's a delayed response sometimes, but that's okay. I might change it so it's like a access point in the future. Yeah, it looks like. Which no, turn right. Okay, that's good. Now let me add the controls for turning right and left. Okay, so in here I'm just going to add elif secondary command. We'll do R. We'll do turn right. Turn right. Connection close. That's right. And then for this one, we'll do, if it's L, we'll do turn left. And it's going to do move, turn left. Okay. So I guess let's see what happens. Let's get out of this loop and save this and reset and open up my app again. There it goes. It seems like sometimes, I don't know if it's through the app or something else. So turn right, turn left, forward. And every time you release the button, it says to stop. So yeah, that's a working Wi-Fi car. Yeah, that was fun. That's it. It's a working project. So I guess next I'm going to be working on refining it. I might try to turn this into an access point so you can just connect directly to the car and control it. But yeah, that's I guess I should move it. That's kind of, I shouldn't just stop it here. I should actually move it on the table. So let me clear off everything here. Let's unplug this. Unplug power. And I just need a clue of the charger still plugged in. Okay. And let's just clear off the desk. I might have to swap some of the directions. I probably won't do that on stream just because you get it. You just swap some of the ones and zeros. And we just put this on the ground. Just tape it on like that. Okay, so I can plug this in. It's going to twitch a little because it does it every time. And now I should be able to control it, so let me just center it first. Actually, all the buttons line up. Sometimes it doesn't register stop, I'm noticing. There it goes. Oops, stop. Anyway, the plan is to be able to control over Twitch. So this is a working Wi-Fi car now. Anyway, it works. I'm going to, yeah, I guess I should put my phone here so you can actually see what I'm doing. There's my phone. Oops. Do turn left, turn right. It seems like sometimes it has trouble with stop registering. But yeah, that is a working Wi-Fi car. I'm gonna stop the stream here and hopefully continue with programming it with Rust soon.